In this video, we're going to look at multiplying by two-digit numbers, as well as multiplying multiple numbers at a time. I'm going to start just by showing you again the standard algorithm, the shortcut. This is likely the way you will want to do it. Afterwards, I'm going to show you over here that sort of long form where we can see a little better what we're actually doing. But my gut is that a lot of you will default to this method, so we'll look at this first. This is also probably the way you've been taught previously. My first step is 3 times 2. So 3 times 2 is 6. Notice I'm starting in the ones column and I'm starting with this 3 as my multiplying factor. 3 times 2 is 6. Now I'm going to continue with that 3 and now go 3 times 3 is 9. And I'm going to write that next to it. Now, because there's nothing else for the 3 to multiply here, we've done the 3 times 2, we've done the 3 times 3, there's nothing over here. That tells us we're going to go down to the next row. Okay? Before we can continue, we always have to put a 0 here to mark the place. It'll be more clear in a minute, but the reason is, now that we're going to use the 9 to multiply, we have to remember this isn't actually a 9, it's 90. So by putting the 0 there, we're pushing our numbers over, our digits, to indicate we're multiplying times 90, not just 9. But because this is a short form, we can think of it as just 9. So the 0 is there, so we can then go 9 times 2, always starting on this side of our top number. 9 times 2 is 18. So I put the 8 down, carry the 1. Notice I was here, so the 1 carries above the next one I'm going to multiply. 9 times 3 is 27, plus the 1 is 28. Now there's nowhere else for me to carry that 2, so I can go ahead and just put the 28 down here. Then I'm going to plus them together. 6 plus 0 is 6. 9 plus 8 is 17, 7 down, carry the 1. 1 plus 8 is 9, and 2 plus nothing is 2. So I'm thinking about it. I like to always check over, does it make sense? 30-ish times 90-ish, it's going to be like 3 times 9 is 27, and there would have been 2 zeros, so yeah, that makes sense. 2,900-ish, sure. It's a little bigger than 30 times 90, so that makes sense. Now, let's do this again. But I'm going to show you what that way where I think we call it the partial product. So you can see, and we're going to add them up as we go. So when I look at this first step, I'm actually just doing, this is the ones column, ones digit. 3 times 2 is 6. Now, instead of thinking of it as 3 times 3, this 3 represents 30 and 32. So I'm going to say 3 times 30 is 90. Now I'm going to look at this 9, and I'm thinking, okay, this 9 actually represents 90. 90 times 2. 90 times 2 is 180. Okay, so we've done 90 times 2. Now we're going to do 90 times 30. That's a little tricky for me to visualize. I'm just going to write it down here. 90 times 30. 9 times 3 is 27, and there'll be 2 zeros. Okay, 27, 2 zeros. So now we've done all the different steps. We've done 3 times 2, 3 times 30, 90 times 2, 90 times 30. So now we add them up. 6 plus zeros is 6, 9 plus 8, 17, 7 down, 1 up. 1 plus 2 plus 7 is 9, and 2. Notice, same answer. This is what we've actually done. We've done it over here. You can see the 6, you can see the 90. This is a little fuzzy, but this is where that 0 comes in. These bottom two numbers, we said 9 times 2 is 18, but really we want to identify the fact that it was actually 90 times 2 is 180. We carried the 1, but you can see it here. And then finally we did 90 times 30, being 2,700. We added that 100 there, so we said 28. So it's the same concept, but this is more visual. I'm going to continue doing it this way. If you want more information about this, come up and see me and we can chat more. This is just as correct as this is. Kids just tend to do this because it's less writing, and this is likely what they've already been taught. This example says multiply 57 times 30. I'm just going to use the standard algorithm. Notice I'm going to rewrite it so it's easier for me to visualize. I'm also going to put that zero, the one with the 0 on the bottom, just because I think that's a little easier. There's nothing wrong with putting it on the top. 57 times 30 is the same as 30 times 57. That is that commutative property we talked about previously, but I like it on the bottom better because then I can go 0 times 7 is 0, 0 times 5 is 0, and put my 0 down. Then I just have to do 3 times 7 is 21, 1 down, carry the 2, be really careful about where I'm carrying it to. 3 times 5 is 15, plus the 2 is 17. Add it together. 0, 1, 7, 1. In this example, they've actually done most of the work for us. We're just filling in some of the missing numbers. This is kind of helping you build to be able to do it all by yourself. So first step, 1 times 8. I like to read it that way. Doesn't make that much difference. 1 times 8 is 8. And then we'll look at 1 times 7 is 7. And then we continue on, the 0 down, 1 times 8 is 8, 1 times 7 is 7, plus it together, 8 plus 0 is 8, 7 plus 8 is 15, 5 down, invisible 1 up there, 1 plus 7 is 8. That's all we need to do. Although the digits in this example are small, it gets a little tricky because the numbers get big fast. So we always work from the left to the right. So 2 times 10, I'm actually going to write it out. Then I can change it as I'm going. So first step, moving from the left to the right, 2 times 10 is 20. So rewriting 20 times 2 times 1. 20, next I'm looking at 20 times 2 is 40. 40 times 1, and the last step, 40 times 1, obviously 40. This example says 76 times 209. Notice that I write the 76, the smaller number on the bottom. It just saves me steps. If we have a 3-digit number on the bottom, where we sometimes have to put that 1 0 down, we have to do another row and put 2 zeros down. Because we only have 2 digits here, it makes it a little simpler. I can explain that more in class time. So otherwise, it's exactly the same as doing a 2-digit by 2-digit. We're just going to start over here with our 6, work our way across, 0 down, then go to our 7, work our way across, add, etc. So let's go ahead. First step, 6 times 9, 54. 4 down, carrying the 5 carefully. Next, 6 times 0 is 0, plus the 5 is 5. Next, 6 times 2 is 12. Nowhere else to carry that 1, so I'm going to write 12. 0 down. Finished with the 6, looking now at the 7. Something I like to do when I have 2 digits is when I'm done with this number at the top, cross it out. Otherwise, you might be inclined to accidentally add it again. So looking at the 7. 7 times 9 is 63. 3 down, carefully carrying my 6. Did 7 times 9, now 7 times 0 is 0, plus the 6 is 6. And lastly, 7 times 2 is 14. Add it all together. 4, 8, 8, 5, 1. Now that is a really big question. I would worry that I might have done this wrong, so I'm going to do a really quick estimation. 76 rounds to 80 times 200-ish. 8 times 2 is 16 with 1, 2, 3 zeros. So my estimate is it's close to 16,000, and my answer was 15,884. Yeah, I was on the right track. Just when it gets so big like this, it's really easy to make a silly mistake. Even if you don't have to, I highly encourage you to check with an estimate. And the last example in this video, notice, so it's 96 times 976. Because of the commutative property, I can switch them, makes it a little easier. I might even show you the difference in steps after over here if I did it this way. Same answer, just one extra step kind of. So, first step, 6 times 6 is 36. 6 down, carefully carrying my 3 to the next digit. 6 times 7 is 42, plus the 3 is 45. 5 down, 4 up. I'm going to scribble this 3 out so it doesn't confuse me. Next step, 6 times 9 is 54, plus the 4 is 58. There's nowhere to carry the 5, so I'm going to write the 58 down here and scribble out that 4. 0 down. Now I'm on to the 9. 9 times 6 is 54, 4 down, 5 up. 9 times 7 is 63, plus the 5 is 68. 8 down, 6 up. 9 times 9 is 81, plus the 6 is 87. Plus it together. 6 plus 0 is 6, 5 plus 4 is 9, 8 plus 8 is 16, 6 down, carry the 1. 1 plus 5 is 6, plus 7 is 13, 3 down, 1 up. 1 plus 8 is 9. Again, a huge number. I think I'm going to do a little rounding and estimating. 96 rounds to 100. 976 rounds to about 1,000. So that would be 1 times 1 is 1 with 1, 2, 3, 4, 5 zeros. 2, 3, 4, 5. So my estimate is 100,000. My answer is 93,000. I rounded up for both those numbers, so it makes sense that that's a little high, but that's relatively close. It's not like off by 100,000, so I'm happy with that. So I just want to show you that I've done the same question, 96 times 976, the way it's suggested here. And you notice I have to do one more row. Still got the same answer. I just find it gets a bit messy. And see how once I did 6 times 6 is 36, 6 down, 3 up, 6 times 9, 54, plus the 3 is 57, 0 down, then I started with the 7, did that multiplication, 7 times 6 is 42, 2 down, 4 up, 7 times 9 is 63, plus the 4 is 67. Then I had to go down to do this 9, another row, then I put 2 zeros. Then I continued as normal. If you really like that way, you can do it. I just think this is a little easier. Okay, that's it for this section. Good luck.